Okay, guys, today we're going to be talking about adding and subtracting fractions, okay, and mixed numbers. This is very important. A lot of you have been exposed to this before, but sometimes you have gaps. So hopefully we can fill in all those gaps and really help you out. Okay, let's first talk about the easy ones. If the denominators are the same, simply add or subtract the numerators and whole numbers and leave the same denominator. It's pretty simple, okay? If the denominators are the same, you simply add or subtract the numerators and keep the same denominator. And then, of course, you simplify. By simplify, it's reducing to lowest terms. And remember that yesterday we talked about how to simplify fractions. Does anyone remember what we do to simplify fractions? Yes, sir. You divide. Okay, he said that you divide by the greatest common factor to both the numerator and the denominator. Okay, so whenever you're adding or subtracting or multiplying or dividing fractions or mixed numbers, you always do want to reduce it to the lowest terms. So, let's do a little bit of a practice here. Should be pretty easy. I got 3 11s plus 9 11s. Same denominator. What do we got? 12 11s. Very good. Now, that's an improper fraction. If you guys remember, an improper fraction is when the numerator is larger than the denominator. How do we change that? How do we turn it into a mixed number, sir? Okay, he says that the mixed number is going to be 1 and 1/11. Okay, just in case anyone doesn't remember or just forgets how to do that, remember, this is really simple. Just divide and use your remainders as fractions. What am I talking about? Well, the 11 is going to go on the outside. The 12 is going to go on the inside. Okay? 11 goes into 12 one time. I have 1 left over. So this is 1 whole time that it goes in, and 1 out of 11 left over. So that's the remainder. Does that make sense to everybody? Awesome. Thank you. Okay, over here, we got 4 12s plus 2 12s. What we got there, my man? That's going to be 6 12s, but we like to reduce to lowest terms always. So this is going to become 1/2. Very good, because you're going to divide 6, which is the greatest common factor, to both the numerator and the denominator. Okay? What do we got over here for number 2 here? 3 12s plus 6 12s. What we got over there, my man? That's exactly right. That's going to be 9 12s. But I think I can reduce that to lowest terms. So what would that be reduced to lowest terms? Yes, sir. 3/4. That's correct, because you're going to divide 3, which is the greatest common factor, to both the numerator and the denominator, giving you 3/4. Very good. Last but not least, I got 7 11s plus 9 11s. What I got there? Okay, yes, I've got 16 11s. Let's go ahead and please turn that into a mixed number. What would I get there? You're going to get 1 and 5 11s. Okay, let's think about this. 11 goes into 16 one whole time. What's left over? 5. So I got 1 whole time and 5 11s left over. Does that make sense so far? Pretty easy? Okay, good. May we continue? Awesome. Okay, let's see. Yeah, that's it. Okay, now, when we're adding and subtracting fractions and mixed number, we're going to continue with this, but this time we're going to talk about when denominators are different, okay? So this is going to be the real deal. When the denominators are the same, that's simple. All right, so let's go ahead and talk about this. Okay, first thing we want to do, whenever you're adding or subtracting fractions or mixed numbers, you want to have a common denominator. The least common denominator would be the best and the easiest for you, but as long as it's just a common denominator, you're going to be fine, because at the end you can reduce, okay, and get your final answer simplified. But whenever you're adding or subtracting fractions or mixed numbers, the first thing you got to make sure is, okay, are my denominators the same? If my denominators are not the same, then I must find the least common denominator, which is the least common multiple. But they call it least common denominator because it's in the denominator spot, okay? Now, number 2, you're going to convert each fraction or mixed number using equivalent fractions. Once you find what the least common denominator is, you're going to figure out how to manipulate the given fraction to have a same denominator, okay? And that's not usually, that's going to happen by multiplying the same number to the numerator and the denominator. Whenever you multiply the same number to both the numerator and the denominator, you change the appearance of the fraction, but not the value, okay? What do I mean by that? If I have 3/5, guys, and I multiply that by 4 over 4, what is the value of 4 over 4? 1. Very good. 1. What's 1 times any number? Itself. So even though this is 12 over 20, 12/20ths, thank you, this is the same value as that. So whenever you're multiplying the same number to both the numerator and the denominator, you're getting what's called an equivalent fraction, okay? And these equivalent fractions are exactly what the word says. They're equivalent. Same value, different appearance. Again, not that you guys don't get it, but just so you could really understand this, all right? 1/2, it's the same thing as 2/4. I just multiplied 2 to the numerator and the denominator. But that's the same as 4/8, which is the same as 16/32, which is the same as 50 over 100. Every single one of these has the same value. It's 0.5 or 1/2. All of them. Does that make sense, equivalent fractions, guys? Okay, so then step 2 is going to be a lot easier then. Awesome. Okay, now we got step 3. Now you're going to add and subtract numerators and keep the same denominators. Then add or subtract the whole number. Just like the last examples that we had, once you have the denominators equal to each other, well, it's easy then. You just go ahead and add and subtract the numerators, and then you add and subtract the whole numbers. And last but not least, simplify the fraction or mixed number to lowest terms. Simplify the fraction or mixed number to lowest terms. Alrighty, so let's go ahead and continue here. As far as the LCD goes, I do want to tell you one thing. A lot of times when we're adding or subtracting fractions and mixed numbers, sometimes it's easy to identify the LCD, or the least common denominator. But sometimes it's not so easy. All right? For example, let's say you're adding 12/17 plus 5/9. 17 and 9, they don't really have an easy common denominator. So when in doubt, okay, when in doubt here, my friends, multiply the denominators to find a common denominator, okay? It doesn't always have to be the least common denominator. In that example that I just gave you, you would just multiply the 9 and the 17. Yeah. And that's going to be 153, and that's going to be your common denominator. And then at the end, you'll worry about simplifying it. But if you can't figure out the LCD right off the bat, when in doubt, multiply the denominators to find the common denominator. Okay? Worst case. All right, let's do a little bit of practice here. The first one's pretty simple. 24/7 plus 9/7. Are the denominators the same? Yeah, so what do we do here in this case? Just add them, right? So it's going to be 33/7. What's that going to be in a mixed number? Yes, sir. 4 and 5/7. Because 7 goes into 33 4 times, which is 28. 33 minus 28 is 5. So 4 and 5/7. Okay? Now, how about number 5? I got 11/4 minus 17/7. Okay, what's happening here? What are you going to do? We can't add these because I got a denominator of 4 and I got a denominator of a 7. What do we got there? Okay, what is the denominator? What's the common denominator? What would the common denominator be here for 4 and 7? 28. Very good. So this is the way I always set this up, and it makes my life a lot easier, okay? I got to convert that 4 to a 28. What did I multiply to that 4 to get to 28? 7. Remember what we just said about equivalent fractions. Whatever I multiply to the denominator, I must multiply to the numerator. Very good. So 7 times 11 is 77. Minus. How do I go from 7 to 28, gentlemen? Multiply by 4. Very good. What's 4 times 17? 68. Fantastic. Now, 77 28ths minus 68 28ths. What's that going to equal? 9 28ths. Can I reduce? No, I cannot. You had a question, sir. Oh, okay. Thank you. Oh, sorry. Thank you. Good man. Does that make sense, guys? All right. 23 thirds minus 12 fifths. What's common denominator here? 15. Very good. How do I go from that 3 to the 15? Okay. So I multiply 5 to 23. What's 5 times 23? Think about it this way. What's 20 times 5? And then what's 3 times 5? So that's 115. See that? Ah, become mathematical geniuses in this class. All right. Minus, how did I get from 5 to 15? 3. This one's easy. What's 12 times 3? 36. Okay. So what are we going to be left with there, gentlemen? 115 fifteenths minus 36 fifteenths. Let's think about that, guys. No, those answers are a little bit wrong. Okay, 79 over 15 is correct. Very good. 79 over 15. And then what's that going to turn into as a mixed number? How many times is 15 going to 79? Goes in 5 times. Very good. 5 times 15 is 75. What's my remainder? Excellent. Does that make sense, y'all? Yeah? All right, awesome. Awesome, 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 awesome. Okay, common denominator here between 17 fourths plus 21 halves. 4. 17 fourths can just stay the same. Plus, how do I get that 2 to become a 4? So I got to multiply the numerator by 2, so that's going to be 42. So that's going to be 59 fourths. And that's going to turn into 14 and 3/4. Very, very good. Very good. Awesome. Because 4 times 14 is 56. Very nice. 19 ninths minus 1/3. What's common denominator here? 9. So the 19 ninths stays the same. Minus, how did I get that 3 to become a 9? Multiply by 3. Whatever I do to the denominator, I do to the numerator. So it's going to be 3 ninths. 19 ninths minus 3 ninths. 16 ninths. What is that in a mixed number, please? 1 and 7 over 9. Very good. 1 and 7 ninths. Excellent. Last but not least, common denominator between 11 and 2. 22. Very good, sir. How do I get from that 11 to a 22, gentlemen? That's exactly right. So it's going to be 36 because I multiply 2 to both the numerator and the denominator. Minus, how do I get that 2 to become a 22? Multiply by 11. 11 times 3 is 33. So that's going to be 3 over 22 because you subtract the numerators. Very good. Does that make sense? Yeah? Awesome. Now, one thing that I forgot to put here as an example, it just came to me. Borrowing. Okay? We went over this yesterday, but I want to go over it again really in detail. So for example, let's say I give you 8 and 2/3 minus 3 and 4/5. Okay? Same procedures are going to be followed. What's the common denominator between 3 and 5 here, gentlemen? 15. Okay. So check out the way I always set this up. This is going to become 8 and something over 15 minus 3 and something over 15. I like to set it up this way because that way I already know my denominator. I know what I have to convert, and we go forward. How do I get from 3 to 15, gentlemen? So I multiply 5 to both numerator and denominator. That becomes a 10. See how easy that is? How do I get from 5 to 15, gentlemen? Multiply by 3 to both top and bottom. 4 times 3 is 12. See how easy that is? Nice and easy, beautifully set up, neat, organized, easy to read. Now, here's the problem. A minus 3, we can do that, no problem. But can I do 10 minus 12? No. If I didn't have whole numbers, I could, and then they would become negative numbers, and we'll get into that when we start adding and subtracting negative values. But for right now, I have a whole number, so I can do something called borrowing, right? So what's going to happen is I'm going to borrow one whole value from the 8, making that a 7. Everyone with me so far? That 1 that I borrowed, I'm going to add that 1 to the 10/15ths in the form of 15 over 15. Now, why? What is the value of 15 over 15? 1. I borrowed 1, I added back the 1. So I'm staying balanced, correct? Now, the second question, why 15 over 15? Why not 5 over 5 or 2 over 2? Because you go by the denominator, because you're going to add these fractions, and in order to add fractions, you need common denominators. So this is going to then become, finally, 7 and 25/15 minus 3 and 12/15, and that's going to equal 4 and 13/15. And that's borrowing. Does that make sense? Are there any questions about adding, subtracting, mixed numbers, or fractions? All right. Awesome. So I may continue? Thank you. Okay, now, multiplying and dividing fractions and mixed numbers. First thing you can tell, I really want you to understand this because I put it in big, bold, red letters. You must convert mixed numbers into improper fractions before multiplying or dividing. You do not have to do that when adding or subtracting. You can, but that's going to be more of a mission for you in my opinion. But when you're multiplying and dividing fractions, okay, you must convert any mixed number into an improper fraction before multiplying or dividing them. So please be careful with that, guys. When I have 1 1/5 times 2 3/7, you must first convert them into improper fractions. Okay? Now, as far as multiplying goes, multiplying and dividing actually, they're both really, really simple. For multiplying fractions, gentlemen, right there. Once converted into improper fractions, if needed, you know, if they're not a mixed number, you don't have to convert anything, of course. Simply multiply the numerator times the numerator and the denominator times the denominator. Then simplify. Done. Literally done. Over. Bye-bye. Okay? Very simple. Now, you can also cross-reduce before multiplying. For example, if I gave you 12/32 times 8/16. Okay, you could go 12 times 8 and then 32 times 16. But Those are large values, okay? And then you're going to have to reduce it, and it's going to take a little bit of time to reduce it. What do you think would be a more efficient way to do this? By cross dividing? Yes, sir. By cross, you can't cross multiply here, no. By cross dividing, yes. So, for example, 8 goes into 8 how many times? One time. 8 goes into 16 how many times? Twice. 2 goes into 2 one time. 2 goes into 12 6 times. 2 goes into 6 3 times. 2 goes into 32 16 times. So 3 times 1 is 3, and 16 times 1 is 16, and it's a lot easier to do it that way. So again, you could have just gone 12 times 8, and then the denominator 32 times 16, and then reduce. But it's much easier to cross-reduce from the beginning, in my opinion. Okay? So again, if I had, let's say, 20 45ths times 18 30ths, for example. Okay, this is a good one. 10 goes into 30 3 times. 10 goes into 20 2 times. 9 goes into 18 2 times. 9 goes into 45 5 times. 2 times 2, numerator times numerator, is 4. 5 times 3, denominator times denominator, is 15. Yes, sir, you had a question. Yes, sir. I didn't go 8 and 4. I went 8 goes into 8 one time, and 8 goes into 16 2 times. You can go up and down or cross. Does not matter. Okay? Either way, you're still going to get the same answer, son. Either way, you're going to get the same answer. Okay? Does that make sense? All right. Thank you. Awesome. Now, dividing. Once converted into improper fractions, if needed once again, you first do stay, change, flip. Then simply multiply the numerator times the numerator and denominator times denominator. Now, let me explain this stay, change, flip thing, okay? Because a lot of times people get confused when they're dividing. If I have 3/5 divided by whatever, 9/15, okay? The first fraction you see stays the same, so hence stay. The division sign changes to multiplication. So you have stay, change, and the second fraction literally flips. So let's put this into motion. Stay, change, flip. Now you multiply like normal. Numerator times numerator, denominator times denominator. But we can cross reduce. 3 goes into 3 one time, 3 goes into 9 3 times. 5 goes into 5 one time, 5 goes into 15 3 times. Look at this. So this is going to be 3 over 3. So in this case, the answer is 1. The important key here is the stay, change, flip. The stay, change, flip. Let's say I have, let's say I have 1 and 1/5 divided by 3 and, let's say, 2/7. Okay? What's the first thing we got to do here since we have mixed numbers? So in other words, we got to convert them to improper fraction, right? So I got 5 times 1 is 5 plus 1, so that's 6/5 divided by 7 times 3 is 21 plus 2, 23 over 7. Then I got to do my stay, change, flip, right? Say it together with me. Stay, change, flip. Again.
Stay, change, flip.
Very good. Stay, change, flip. So stay, change, flip. You cannot cross reduce here. You're out of luck in this case. 6 times 7 is 42. 23 times 5 is 115. You're golden. That's it. You cannot reduce anymore. Does that make sense so far? Promise? Okay. Awesome. Got 5 minutes left, so let's practice. Come on. Let's go, computer. It's working. Hold on. Hold on. While it's working, I'm just going to pause it till it starts working. All right. We're back. All right. Let's see what we got here. Let's run through this because we don't have that much time. I got 9/5 minus 5/8. What's common denominator? 40. So this is going to go to a 40. That's going to go to a 72. Minus, that's going to go to a 40. And that's going to go to a 25. So 72 40ths minus 25 40ths. (47 40ths). Very good. And 47 40ths, that's going to equal 1 7 over 40. Excellent. Okay. We don't know much about integers yet, but let's just go ahead and pretend that's a positive 1 and a positive 2. Okay. And I've got 1 plus 2 2/5. What do we do in that case? That's nice and easy. What do we do here, guys? Okay, yeah. When you're adding them, you just leave it like that, and that's going to become 3 2/5. Now, someone mentioned something that was really good. What if it was 4 or just the 1? How about that? 1 minus 2/5. What would you do in that case? Huh? No, it's not going to be a negative. What's happening here? 1 minus 2/5, what would it be?
Make it 5 over 5.
Thank you. You're going to go ahead and convert this 1 into a 5 over 5. What's the value of 5 over 5, boys? 1. So 5/5 minus 2/5 is 3/5. Does that make sense, guys? You with me? You promise? Okay. Bell's about to ring. So thank you very much, and have a great day. Okay, so let me now. Now it's recording. All right, guys. Now, don't worry about the negatives for now. Just pretend they're positives. I got 5/4 times 1/3. What's that going to be? 5/12. Yes, numerator times numerator, denominator times denominator. Done. 4/9 times 7/4. What did I do first here, guys? Okay, you could go 28 over 36, but what would be a much easier way, my brothers? Cross divide. Very good. Those 4's cancel, and I got 7/9. How about 8/7 times 7/10? Okay, first of all, cross divide the 7's, and then very good, Christian. 4 goes into 8 2 times. Oh, I'm sorry. 2 goes into 8 4 times. Hello. And 2 goes into 10 5 times. So that's 4/5. Excellent job. Pretend that's a positive. 2/3 times 5/4. Okay. Well, you could do 10/12, or cross divide. The 2 goes into 2 1 time. 2 goes into 4 2 times. So that's going to be 5/6. Does that make sense, boys? Okay. 9/7. No, nine. That's 5. That's 5/6. Okay. 5/6. Real quick. Let's say this was division. 2 divided by 3/7. Remember, stay. Hold on. Change. Flip, which is going to be 14/3, which is going to be 4 2/3. Thank you. May God bless you all. Have a great day. Thank you for a great lesson.